The video effectively captures the fundamental Hello World project in the world of microcontroller programming, the LED blinking circuit. This exercise is executed flawlessly within the Tinkercad Circuit Simulator, a crucial online tool that allows beginners to test hardware and code virtually before attempting it with physical components, thus avoiding damage and simplifying the learning curve. The process begins with the user accessing the Tinkercad platform and creating a new circuit workspace, establishing the digital environment for the entire project. The core of the circuit involves an Arduino UNO R3, which serves as the brain, and three external passive components: an LED, light-emitting diode, a 220-ohm resistor, and a small breadboard. The LED is placed on the breadboard with its anode, positive leg, connected via a wire to digital pin 5, D5, on the Arduino, which will supply the programmable voltage signal. Crucially, the cathode, negative leg, is connected through the 220-ohm resistor to the GND pin of the Arduino. The resistor is an indispensable component, as it limits the current flowing through the LED, protecting it from being instantly destroyed by the Arduino's output voltage, a vital lesson in basic electronics known as Ohm's law. The LED blink is deceptively simple, yet it contains the single most important hook point for aspiring makers and engineers: digital output control. This demonstration shows the absolute power of a microcontroller, the ability to physically control a real-world component, the LED, merely by writing a few lines of code. The code itself, built using Tinkercad's user-friendly blocks interface, is a simple repeating sequence, the forever loop, that executes two main commands: set pin 5 to high, followed by a wait 1 sec delay, and then set pin 5 to low, followed by another wait 1 sec delay. The simulation beautifully illustrates this interaction, where the virtual LED switches on and off every second, proving that the code is correctly interacting with the simulated hardware. The ability to instantly change the LED's color during the simulation further highlights the powerful flexibility of using a virtual environment to prototype ideas quickly. This foundational concept, controlling voltage and timing via programming, is the gateway to every complex project imaginable, from robots and sensor networks to home automation systems, making the blink circuit the critical first step on the path to embedded systems mastery.